What is electronegativity? So let us first understand this by a story. Let us imagine that there are two roommates living in a room, and there is some things which are kept here. So one is very rude and wants to keep all of this and is very strong. So he will manage to get most of the stuff, while this weak person will not get much of the things which he wants. Similar goes in here. Ideally, if there are two atoms A and B, they should stay together and the electrons which are shared between them should stay equally between them. But instead what happens that if there are two atoms A and B, so it will hog, the atom A will hog or atom B will hog electrons much more, which will cause this unequal distribution, since atom A is much stronger than B. Similarly, it can happen in very common molecules like H2O. So let me draw H2O. So this is O and the H and H. So O is much more powerful at hogging electrons. So what will happen? These electrons which are floating in here will move towards this side, and instead of looking like this, it will look something more like in this. This is the 2H, and the electrons will mostly stay in this side instead of being equally distributed. And there is a scale known as Pauling scale, which basically tells the strength of the atom. This basically tells the strength of the atom. And in the periodic table there are some trends. So let us just draw a quick periodic table. Let us imagine that this is the periodic table, and these are all of the elements. So when we go along the period, the electronegativity increases. It increases, and as we go down the group, it decreases. The electronegativity character decreases. So the strongest element in terms of electronegativity is fluorine with a Pauling scale of 4.0, which means, so now let us look at our example again, the water example. This is our O and this is the H. So as we have seen earlier, most of the electrons go in here, and O mostly completes their octet and H also completes their duplets. But there is a slight negative charge at the top and slight positive charge at the bottom, since there are less electrons in the hydrogen side and more on the oxygen side. So this basically creates like a battery like structure, almost like a battery where one side is negative and the other side becomes positive. So this is very useful when these get together. So they can now get together like this, O H H, and then they also get attached here, O H H, because they also got their charges attracting each other. So this helps increase the strength, increase the boiling melting point of these compounds when they are put in a when they are put in beakers and other things. Thank you.